Hello, this is Mr. Fay. Today we're going to do a quick review as to how you compute density. So we're going to take this object that you see here in the upper left-hand corner, and we are going to calculate the density of this cube that has a volume of 15.6 cubic centimeters and a mass of 45.3 grams. In order to do this, we need to use the formula that we've been using in class, which is density is equal to mass divided by volume. Now, luckily, the way this question is set up, it's pretty easy to find the information. And so we need to know the mass, we need to know the volume from the question in order to solve the problem. And if we take a look up here, it shows you calculate the density of this cube that has a volume of 15.6 cubic centimeters, which makes this your volume right here, which I'll write down here in red. 15.6 cubic centimeters. The mass is also easy to pull out because it says, and a mass of 45.3 grams, which makes our mass 45.3 grams. Great, now that you've identified the information, we need to do our substitution in the computation box. So instead of writing the mass, which we have up here, we're actually going to put the value in, which is 45.3 grams. Please note that I'm keeping the unit with it because that will pay dividends a little bit later on. Then we take a look at the volume. We don't write the word volume. We actually find the volume from the problem, and we put it right down here, which is 15.6 cubic centimeters. All right, we're ready to use the calculator, so let me pull this up very quickly for you. This is actually a pretty common mistake, and normally I wouldn't show this, but 8th graders very often will get nervous when they see these two numbers, and they need to realize that you need to make sure that you are always putting the top number in the calculator first, okay? Regardless of whether it's bigger or smaller, you always want that top number in the calculator first. So the mass is going in first. Let's check it out. We have 45.3 grams divided by the volume of 15.6 centimeters cubed. And when we do that, that shows that we have this huge number past the decimal. Our answer is actually 2.90, and I lost my calculator, but it's a whole bunch of digits, and it doesn't really matter. Because we usually measure to the nearest tenth, we're actually going to round our densities to the nearest tenth also. So we're really only concerned about these numbers right here because we want to go one digit past the decimal. Now when you do this rounding, the question is, does this stay 2.9 or does it go up to 3.0? And again, all you do is take a little peek over at that number there. And since it's a 0, we'll keep it at 2.9 and disregard the rest of the number. So our answer is officially 2.9. Now for units, you might remember that I asked you to keep the units back here in the substitution because they'll help later. They sure will, because there's your unit. Since in the actual computation itself, you took grams and you divided it by cubic centimeters, that is simply the unit. So remember, units do not need to be memorized. They can be figured out by doing your substitution from your formula. So if you're ever given a a density question that uses the volume measurement of milliliters instead of cubic centimeters, that would change the substitution down here, which would then change your unit over here. So you can either memorize the unit or actually figure it out by looking back in the substitution box. Hopefully that helps you out a little bit. Have a good one. Good luck on all your density solving endeavors.